So we'll start with problems for the chapter vector algebra, and the first problem is here right in front of us. So we need to find the value of OA vector plus OB vector plus OC vector plus OD vector, where ABCD is a rhombus whose diagonals cut at the origin O. So how do we go about it?
In this question we will be using a special property of the rhombus, that is their diagonals bisect each other. So we will be considering the diagonal AC. Now for AC diagonal, OA bar plus OC bar by 2 will be equal to OO bar.
Because it's at the origin.
Yeah. But OO bar is equal to 0 bar.
The zero vector in the coordinate system, correct.
Therefore OA bar plus OC bar will also be equal to 0 bar.
Right.
Now similarly OB bar plus OD bar will also be equal to 0 vector.
Okay.
So adding these two equations we get it.
Yeah, so it's fairly simple since OA vector plus OC vector, the midpoint for this line segment or for this vector is at the origin, so it is the zero vector. And similarly for the other diagonal. Another way to look at it would be the fact that since diagonals bisect each other, the vectors OA and OC will be in exactly opposite direction and of equal magnitude. So they'll cancel each other out, and then similarly for the other one, and hence the total sum will be 0. Okay, so what would happen if it was not a rhombus and something else? Let's say if it's a rectangle which is not a rhombus. Does this hold for a rectangle as well?
It will hold for the rectangle.
So what is the necessary condition for this sum to be 0?
Actually it comes from the bisector formula, section
Exactly.
formula.
So any quadrilateral in which the diagonals are being bisected will have this property.
Yeah.
Correct. So that is it for question 1. Let's move on to question 2 now. So problem 2 states that if A, B, C, D are any 4 points and E and F are middle points of AC and BD, then we need to find the value of AB vector plus CB vector plus CD vector plus AD vector. So here A, B, C, D are any 4 points and they don't have any special relation about them, and E and F are just midpoints of AC and BD. So
in this question, as F is the middle point of BD, therefore AB bar plus AD bar by 2 will be equal to AF bar.
Correct.
And CB bar plus CD bar by 2 will be equal to CF bar.
This is the midpoint formula, which is like a special case
formula.
of the section formula. Correct.
So adding these two equations we get AB bar plus AD bar plus CB bar plus CD bar equal to twice AF bar plus CF bar.
Right.
Now since E is the middle point of AC,
Right.
therefore this will also be equal to twice 2 times of EF bar,
Correct.
that is equal to 4 times EF bar.
EF bar. And that's our solution.
Option B.
Option B. So that's correct. So here again, this doesn't need to be anything. There doesn't need to be anything special about the 4 points or their midpoints for this relation to hold true. It'll almost always hold true if there are two midpoints. So this is a very basic problem, and it's not really a problem as such. It's just how you can approach
Application of
things.
section formula.
Exactly, and things like these will be, without being mentioned, used in further problems here and further when you practice also. So that's it for question 2, and we'll move on to question 3 now. So we'll look at the third problem now, and it says that if A, B and C are 3 non-coplanar vectors such that A vector plus B vector plus C vector is equal to X times D vector, and B vector plus C vector plus D vector is equal to Y times A vector, then we need to find the value of A vector plus B vector plus C vector plus D vector. So yeah, lots of vectors and lots of things to work with. So how do we start with this?
So here it is given that A vector plus B vector plus C vector is equal to X times D vector.
Right.
So adding D vector on both the sides we get A vector plus B vector plus C vector plus D vector.
Because we found the form that we need to find the value of, right?
Yes, exactly. X plus 1 times D vector. Similarly we get A vector plus B vector plus C vector plus D vector is equal to 1 plus Y times A vector. from the second given condition.
Right.
Now equating from the two equations, we get x plus 1 times d vector is equal to 1 plus y times a vector. Now let's assume that x is not equal to minus 1.
Okay. So that we can arrive at a relation between a and d vector directly.
Exactly. So we get 1 plus y times a vector upon x plus 1 d vector equal to. So here we can substitute the value of d vector in equation number 1.
Yeah.
So what we get is a vector plus b vector plus c vector is equal to x times 1 plus y upon 1 plus x times a vector, which further implies a vector times 1 minus x whole into 1 plus y upon 1 plus x plus b vector plus c vector is equal to 0.
Yep.
Which implies that a vector, b vector and c vector are linearly dependent vectors.
Right.
So which implies that they are coplanar vectors.
Correct.
But it is given in the question that there are 3 non-coplanar vectors.
Right.
So our assumption is wrong. So
Exactly.
it implies that x is equal to minus 1.
Correct.
So what we get is a vector plus b vector plus c vector is equal to minus times d vector.
Right.
So we get a vector plus b vector plus c vector plus d vector is equal to 0 or null vector.
Exactly. So yeah, that is the solution here, and you can see that it involved the rejection of an assumption, which is fairly uncommon when people get down to solving JEE problems. People don't usually think that what they assume is going to be neglected, especially a condition like x not being equal to minus 1, because when you express d vector in terms of a vector, x plus 1 lies in the denominator. So the first thing people assume is that x would probably not be equal to minus 1, but here this is not the case, and because of that we arrive at the sum being equal to 0. So that is it for the third question, and we will move on to the fourth one now. Moving on to the fourth problem, it says that a vector A has components 2p and 1 with respect to a rectangle Cartesian system, which is what we are familiar with. This system is rotated through a certain angle about the origin in the counterclockwise sense. If with respect to new system, A vector has a component p plus 1 and the other component is 1, then we need to find the value of p. So it involves the rotation of the coordinate system, and we need to find the value of p such that the new components are these. So how do we get on with that?
Generally, after reading this question, what people do, they assume the angle theta and then take the components and they solve.
Right.
But
because there are formulas for rotation and people try to use them.
But this method is a bit longer one. We will have a shorter method. Actually, if we try to see the question very closely, the vector is the same, so its magnitude is going to be the same. That is what is the catch in this question, a particular JEE question. So let's assume so the initial vector be a bar, which will be equal to 2p I cap plus 1 times j cap.
Right.
And the final vector be b bar equal to p plus 1 times I cap plus j cap. As the vector is the same,
so its magnitude
is
will
going
be
to be the same.
Constant. Correct.
So 2p plus 1 the whole square plus 1 root will be equal to the root of p plus 1 whole square plus 1. So solving this equation, squaring and solving, we get p equal to 1n minus 1 by 3.
Okay, so that happens to be option B, so our solution is probably correct, and it makes sense because it's very simple. So you saw that how confusing questions can often lead you to very complicated theory which you would probably not remember in the middle of an exam, because it's not often used and it's not something that will be asked to you in a paper which has a time limit and all those things. So which was very simple here. We just had to notice that the vector was the same, so nothing about it has to change no matter what the coordinate system does.
Most of the questions are solved by just the basic thinking.
Yeah.
if we go by the basic line.
Exactly. So this was very simple. In fact, it reminded me of so many JE questions that I've practiced and gone through, where people were led to very complicated concepts, but those were actually never used. So that is it for problem 4, and we'll move on to problem 5 now. So we'll look at problem 5 now. It says a vector c of magnitude 20 root 6 directed along the bisector of the angle between a vector, which is given to be 7i minus 4j minus 4k, and b vector, which is minus 2i minus j plus 2k, is what? So here we are given two vectors and we are told that vector c is along the angle bisector and we are given its magnitude.
So here we will consider a triangle AOB with O at the origin and A and B respectively at the A vector and B vector.
Right.
Also consider a point E on the line AB such that OE is the angle bisector of AOB.
Correct.
Now here we will be using the angle bisector property which states that OA upon OB is equal to AE upon
B.
B.
Right.
So now here length OA upon length OB will be equal to magnitude of vector A upon magnitude of vector B.
Correct.
Which turn out to be 9 by 3, that is 3:1.
Yeah.
So we can say that AE upon BE
Right.
is 3:1.
3:1. Right.
So which implies that point E divides AB in the ratio 3:1.
3:1. So now we can work with the section formula.
Yeah.
Correct.
So E bar will be equal to 3B bar plus A bar upon 3 plus 1.
Right.
So after manipulating, we get E bar equal to 1 by 4 times I cap minus 7J cap
Right.
plus 2K cap.
Okay.
Now as we want the vector to be of magnitude 20 root 6,
Right.
so first we will divide this vector by its magnitude.
So that we find the unit vector in that direction.
Yes,
Right.
exactly. And then we will multiply it by 20 root 6.
Okay. So yeah, that's all we have to do here. And fairly simple problem again. When we are given that C lies along the angle bisector of these two vectors, we use the simple geometrical property of a triangle and we obtain a relation between the magnitudes, and then we find the unit vector and multiply it with whatever magnitude we need it to be. So that was problem 5. We'll move on to problem 6 now. So problem 6 says that the length of the longer diagonal of the parallelogram constructed on 5a vector plus 2b vector and a vector minus 3b vector, if it is given that a vector mod of a vector is 2 root 2 and mod of b vector is 3 and the angle between a vector and b vector is pi by 4. So we need to find the length of the longer diagonal given that mod a is 2 root 2 and mod b is 3 and their mutual angle is pi by 4.
In this question, first of all, we will have to find out the diagonals,
Right.
so that we can find which one is the longer.
Exactly.
So for the diagonals, one of the diagonal is given by the sum of the vectors and the other one is given by the difference of the vectors. As this comes from the parallelogram law of vector addition.
Right.
So suppose the first diagonal is d1. So d1 bar will be equal to 5a bar plus 2b bar
Okay.
plus a bar minus 3b bar, which turn out to be 6a bar minus b bar,
Right.
and d2 bar will be equal to 5a bar plus 2b bar minus a bar minus 3b bar.
So actually in this question we can either find both diagonals and compare which one is bigger, or otherwise we'll have to actually find out that these two are whether they are edges in the same clockwise sense or whether they are in different directions. So the shorter approach here would be to just find the two diagonals no matter what they are and just find the longer one, because that is what the question asks. Right.
So now we have to find the length. So magnitude of d1 bar will be equal to magnitude of 6a bar minus b bar, which can also be written as under root of mod of 6a bar minus b bar
Correct.
square,
Yep.
which will turn out to be under root of 36 mod a square
Right.
plus mod b square minus 12 times a bar dot b bar.
Right.
After
A bar.
a bar dot b bar, yes.
Correct.
Which will turn out to be 15. Substituting the value of mod a and mod b.
Yep.
And similarly, we can find mod d2,
And which comes out to be what?
root 593.
Okay.
So as root 593 is greater than 15,
Right.
so d2 will be the longer diagonal, and the
Okay.
length of the longer diagonal will be root 593.
Okay.
So it will turn out to be option C.
Yeah. So here we saw that we were given two edges of a parallelogram, but we didn't know whether they are in vector sense they are along the same cyclic direction or not. For example, we didn't know whether, let's say, the base was given, and we didn't know which of the two other sides was given, right? So a good way in such situations is to simply find the two diagonals because they involve only addition and subtraction, and just check which one is longer.
Again, a simple approach can make it easy.
Exactly, and if you try to start finding out which one can be what, we know nothing about a vector and 2b vector, so it doesn't make sense to go about wondering in which sense the vector directions are, right? So that was problem 6. Moving ahead with problem 7, it says if a vector and b vector are unit vectors and theta is the angle between them, then mod of a vector minus b vector by 2 is what?
So here, as we have to find mod of a vector minus b vector by 2, so we will think such that we can find the value of mod of a vector minus b vector. So we will begin with mod of a vector minus b vector the whole square,
Okay.
which will turn out to be mod of a vector the square plus mod of b vector the square minus 2 times a bar dot b bar.
Okay.
Now as a bar and b bar are unit vectors, so their mod square will turn out to be 1, and a bar dot b bar is mod a mod b cos theta,
Correct.
which will further turn out to be 2 minus 2 cos theta.
Okay.
Now from simple trigonometry relation we know that cos 2a is equal to 1 minus 2 sin square a.
Right.
So 2 sin square a will be 1 minus cos 2a. Similarly, 1 minus cos theta will turn out to be 2 sin square
theta by 2.
theta by 2.
Right.
So substituting here, 1 minus cos theta will
Okay.
turn out to
So that'll
be
be
sin square theta by 2.
right. So that means mod.
So mod a square, mod of a bar minus b bar the square
Yeah.
is turning out to be 4 sin square theta by 2.
Correct.
So
Yeah.
by 4 will turn out to be sin square theta by 2.
Right.
Taking square root on both the sides, get mod of a bar minus b bar by 2 is sin theta by 2.
Correct.
That is option A.
So again, this problem appears very simple, but that is only because we decided to square it as soon as we began. Otherwise, yeah, there are ways to wonder about this, and it might take time. So there was problem 7, and we will move on to the 8th one now. So we'll look at problem 8 now. If in a right angle triangle ABC, the hypotenuse AB is given to be B, and we need to find the value of AB dot AC plus BC dot BA plus CA dot CB. So we're given the hypotenuse, and we need to find the sum of dot products of the sides taken two at a time.
So in this question, ACB is the right angle triangle with right angle at C,
Okay.
and AB is P. As we have to find dot products,
Correct.
so we will consider angle A to be theta.
Right.
So angle B will turn out to be 90 minus theta.
So that we can have the term cos theta.
Yeah.
Right.
Now AB dot AC will turn out to be AB times AC times cos theta
Correct.
plus BC dot BA will turn out to be BC times BA
Right.
times sin theta,
Correct.
as cos of 90 minus theta is sin theta,
Yep.
plus CA bar dot CB will turn out to be 0 as
So-
angle C is
Exactly.
0.
So we'll put that 0 right now so that our steps are reduced. Okay.
Now cos theta will turn out to be adjacent upon hypotenuse, which
Right,
is
right.
AC upon AB,
Correct.
and sin theta will turn out to be BC upon AB.
Right. So that
So
means
substituting these values,
it'll just be AC square plus AB square.
it will turn out to be AC square plus BC square,
Right. BC square. Sorry.
which is same as AB square
which is p square.
Which is p square.
Okay, so an interesting thing to see there. This actually can be a general property of every right angle triangle because there is no specification given here. There is no loss of generality.
Yeah.
Okay, so that is problem 8, and we'll move on to the next one now.